Hi, everyone. Welcome to the EduAvenues TJ Test Prep YouTube channel. Through our YouTube videos, we hope students gain an understanding of how to approach and solve different types of math problems seen on the TJ problem-solving essay. Even if you got the problem right, watch this video as you can learn helpful problem-solving strategies that you can then apply to other problems. If you want to learn more about our services, please visit tjtestprep.com. Today, we will be going over the real math and science problem-solving essay from the 2022 TJ admissions exam. Again, this is the actual essay prompt for the TJ admissions test, which was administered on January 29th, 2022. Now, on to the problem. For some background knowledge, before doing anything else, please watch the following videos in order to gain a better understanding of how Punnett squares and genetics work. The links are in the description as well. If any of the following terms look unfamiliar to you, you will likely need these videos before moving forward. Dominant, recessive, allele, homozygous, heterozygous, Punnett square, genotype, and phenotype. So the question that appeared on the 2022 exam is, human genetics is incredibly complicated. Punnett squares are a useful model for determining the genotype of single traits. Though eye color is influenced by many factors, we can generalize brown eyes to be a dominant trait, denoted by a capital B, and blue eyes, lowercase b, to be a recessive trait. If two brown-eyed parents mate, will all of their offspring have brown eyes? Why or why not? And can any potential grandchildren have blue eyes? Fully explain your answer in essay format. At this point, please pause the video now to try to solve the problem before we go over it together. All right, before we solve this problem, we can begin by creating a framework. Our first step is to map out Punnett square input scenarios for all of the children. The second step is to compute the outputs for these Punnett squares, along with the associated probabilities that each of these outputs might occur. The third step is to map out the scenarios for all the grandchildren, so this is the step after the initial children, and draw an immediate conclusion from that. And finally, we can discuss assumptions that went into solving this problem and any contextual elements. So for the prompt, we know two things. An uppercase B represents brown eyes, which is a dominant trait, while lowercase b represents blue eyes, which is a recessive trait. Given that both parents have brown eyes, which is a dominant trait, we can say for certain that the parents cannot have lowercase b genotype. This is because both parents have a dominant trait. So one of their alleles has to be an uppercase B. This leaves us with a few other options. Either both parents could be homozygous dominant, and in this scenario, we have brown eyes. We have these are denoted by a capital B. It's clearly displayed because that's the only option. The second consideration or second option that we have is a heterozygous combination. In this scenario, we have also brown eyes because we have at least one capital B here. And the reason why the brown eyes are displayed and not blue eyes is because it's a dominant trait. A dominant trait would kind of override the recessive trait in terms of what actually gets shown. And this final option, homozygous recessive, that's where we have two lowercase b's. Again, that's not possible for the parents because that would imply that the parents are blue-eyed, but the problem already told us that the parents are all brown-eyed. So it's not possible to have two lowercase b's. And now that we've mapped out the possible inputs, we can now map out possible mating pairs. So the three possible combinations from this are uppercase B, as well as uppercase B. That's a homozygous dominant mating with another homozygous dominant. We have two uppercase B's and then uppercase B, lowercase b. That's a homozygous dominant mating with a heterozygous. Or we could have a heterozygous mating with a heterozygous. So that would be one uppercase B, one lowercase b mating with one uppercase B, one lowercase b. Those are the only possible combinations. Again, the lowercase b would not be an input option into this because that would imply that the parents have blue eyes. They, once again, have brown eyes. And the second step is to create the Punnett square. Using all of these pairs that we came up with, we're going to go and create Punnett squares. So these can help us map out the possible outcomes for the children when these parents mate, as well as the probabilities associated with each one. So in terms of setting up the Punnett squares, we would lay out each of the parents' alleles on each of the two axes. So imagine, let's take this first Punnett square in the top left corner, for example. We have a homozygous dominant mating with another homozygous dominant, and these have or each of the parents has two alleles that they could possibly pass down, the uppercase B and an uppercase B. And then we would then go and put those two alleles on each of the axes respectively, and it gets passed down according to color. So these B's are associated with each other, these B's are associated with each other, and so on. And these, what's left in the square is our final output. So those are the possibilities for the children. We do this for all of the Punnett squares. And this one in the top right corner is probably the best example, where we have two heterozygous parents mating. So we have a uppercase B, a lowercase b, and then another parent with an uppercase B and a lowercase b. And here we have in this top left square, we have both of the dominant alleles being passed down. In the square just to the right of it, so the top right, we have one uppercase B, the pink one, being passed over, and then we have the lowercase b. And in this case, if we have a one upper and one lower, the brown would display because it's the dominant trait. Same thing in the bottom left corner, and in the bottom right, we have the recessive allele for both parents being passed down. And if we have lowercase b, then we end up with blue eyes. So in total, and looking at all of these different possibilities and all these different outcomes, we have a total of 12 outcome squares, right? So this would be a square, this would be a square, this would be a square, and so on. And then we have 3 unique possible outcomes. So we end up with 7 squares or children where we have uppercase B output, so homozygous dominant, which would lead to brown eyes. We have 4 squares of uppercase B, lowercase b output. Those are heterozygous, leading to brown eyes as well, because the dominant trait, the uppercase B, would display. And we have 1 square of lowercase b, leading to blue eyes. And that's the critical point there. That's something that we have to keep in mind moving forward, is that we do have this one child with the possibility of blue eyes. So, using the Punnett squares that we built from the previous slide, we can now determine the probability of children having brown eyes versus them having blue eyes. So we can add up the 4 squares of homozygous dominant genotypes and 7 squares of the heterozygous genotype to get a probability of 11 out of 12 for brown eyes. And for blue eyes, we can see that there's only 1 square over here with the probability of getting a lowercase b genotype, indicating blue eyes. So the probability of children getting blue eyes is a 1 out of 12, or an 8.3% chance. This clearly answers our first question, that all offspring do not necessarily have brown eyes. It's very possible that a fraction of them have blue eyes. And in the long run, this would be about 1 out of 12, or 8.3% of offspring. However, something to keep in mind here, they don't necessarily state how many offspring there are. And the results of the eye color might vary based off of the number of offspring produced. So if we only have 2 or 3 offspring, it's more likely than not that all of them are going to be brown-eyed. But let's say we have thousands of offspring. We're more likely than not, actually extremely likely, to have at least a couple that have blue eyes. So that's something to keep in mind, and something that can be discussed in the assumptions that we'll talk about later. So I guess the next step here would be to look at the grandchildren, right? Now that we've looked at the children, we can go ahead and look at the next level of this. So as mentioned before, the children have only 3 genotypes. We have uppercase B, uppercase B, lowercase b, and then lowercase b. And using that information, we can now find different mating pairs where the children are now mating together and producing more children. So they become the ones that they produce become grandchildren. So using that information, we can find these mating pairs. There could be a homozygous dominant mating with another homozygous dominant, a homozygous dominant mating with a heterozygous, a homozygous dominant mating with a homozygous recessive. And in all of these mating pairs, we will always end up with at least one dominant allele being passed down. So these three don't necessarily produce any blue-eyed grandchildren. But when we look at these bottom three here, the ones that are highlighted, where we have a heterozygous mating with a heterozygous mating with a homozygous recessive, and a homozygous recessive mating with a homozygous recessive, we do have possibilities where we have two lowercase b alleles or blue eye alleles being passed down. So that right there answers our question that yes, grandchildren can have blue eyes, again, with enough grandchildren produced. So every problem has a set of contextual elements that can be detailed further that may impact the results of the problem. We call these assumptions. If you end up with some additional time at the end, in addition to checking over your work, you can detail these further. So one big assumption that we can talk about here is that there's always the possibility of a skewed probability due to chance, right? These numbers that we computed are only estimates and approximations. These aren't exact figures. In addition to that, in order to use probability effectively, we would need a large enough sample size on the offspring. So like we can't just have a couple of offspring and definitively say, yes, they're all going to be brown, or they're all going to have blue eyes, or a certain percent will have blue eyes. For our calculations to work, we would need a large enough sample of offspring to definitively see blue eyes with an extremely low probability of that failing. So, we'd be looking at, dozens, hundreds, thousands of offspring. And then finally, when we think about science, another thing to keep in mind is that genes can mutate and change over time across generations. So, especially when it comes to eye color, there may be environmental considerations that impact exactly what happens in the real world. So Punnett squares are just mapping out what's most likely to happen, but there are of course other factors that might play into it. And when we think about our final answer, that's always something we want to state very clearly. We would usually put it in bold at the end, or even up front if you're very confident in it. Is that one, all offspring do not necessarily have brown eyes. It's very possible that a fraction of them do have blue eyes. And in the long run, that would be about 1 out of every 12 or 8.3% of the offspring. And to answer the second question on grandchildren, yes, potential grandchildren may have blue eyes as well. So that wraps up our video and our solution to the 2022 real exam prompt. We do a lot of work in the TJ admission space. So for similar solutions, practice prompts, and complete instructional materials on how to ace the TJ admissions process from end to end, we highly recommend working with us. We have a couple of different products that we offer: small group coaching, a self-paced online course. Last year, we had an 81% admissions rate to TJ. That's even higher for students who have a 3.7 or above GPA. Another thing that you can check out that's a free resource, we have an admissions blog at tjtestprep.com/blog, and that includes special insights, tips, and tricks. We also have a data and insights page where we go through how TJ admissions was impacted by the recent changes. And if you're looking for more broad educational material, we also have our parent company, EduAvenues.com, and you can take a look at our mathematics, coding, and college admissions boot camps there. Of course, if you have any questions at any time, please feel free to send us an email at tjprep@eduavenues.com.